Today's video is about the celestial sphere. The celestial sphere is how we can consider the stars in the sky. If we consider the Earth to be in the center of a giant hollow sphere and the stars to be embedded on the inside of that sphere, that allows us to think about how the sky moves and where stars are. Here we have the Earth, and here we have the celestial sphere. The celestial sphere has a north pole directly above the Earth's north pole and a south pole directly below the Earth's south pole. It also has an equator, which is the extension of the Earth's equator. Now here we have another representation of this time it's tipped on its side. Here we have a man standing in North Africa, not to scale. Here's the Earth's equator, here's the North Pole and the South Pole. The extension gives us the North Celestial Pole and the South Celestial Pole. And here we have the celestial sphere where all the stars are. You can see here that there's this plane, which is the horizon for this man standing here. That is to say, he cannot see below it. So he can see the stars in this hemisphere, and he can see all the stars in this hemisphere. The Earth is turning, and therefore the celestial sphere appears to be turning. And so what you get is stars rising in the east, going over the top of the celestial sphere and coming back down in the west. So stars rise and set just like the sun and moon rise and set. And so here we have for this guy, if he looks to the north, he'll be looking in this direction, and somewhere above the horizon he'll find the pole star, the North Star. He'll see stars rising over here and setting over here. There'll be stars down here that he can't currently see, but wait a little while and they will rise and set. However, there are some stars down here that as the Earth turns and the celestial sphere appears to turn, will never come above the horizon. This is one of the reasons we need to have observatories all over the world. From a northern hemisphere location, there are some stars in the southern hemisphere that you cannot see, and vice versa. Likewise, you can see here, there are some stars that never go below the horizon. So, for instance, the Plough, or the Big Dipper, is part of Ursa Major, and that is a circumpolar constellation. That is to say, it goes around and around the North Star, but it never ever sets. Now let's consider the pole star. So here we have another Earth. We have another man standing at a different location. This time he's at 45 degrees, so that's approximately the same latitude as Minnesota, and he's even less to scale than before. We can see the celestial sphere. The zenith is the point directly above his head. It is always the point directly above your head. If you're at the North Pole, it is also the North Celestial Pole, but the zenith is just the point above your head. He has a horizon marked by this plane here. Here's the equator of the Earth, so here's the equator of the celestial sphere. And so what we've got is the position of this guy in terms of latitude can be determined from the position of the North Celestial Pole. So remember, this is this guy's horizon. If he looks to the north, he looks in this direction, and then he has to look up through a certain angle to find the pole star, which is directly above the North Celestial Pole. It's right here. This guy is standing at this latitude, and if we do some simple geometry, we find that this phi angle, that is his latitude, is actually the same as this angle, phi, and so the angle between the horizon and the pole star gives you your latitude. So, how high in the sky would we have to look to find the pole star from Columbia, assuming we're already looking north? Well, we need to know where we are. So what is the location in terms of latitude and longitude? For Columbia, we're at about 39 degrees north and 92 degrees west. And so that means that you have to look up through about 39 degrees in order to find the pole star. I suggest you go and try it. The pole star will be used to determine the latitude wherever you are in the northern hemisphere. But if you're in the southern hemisphere, you can't see it. Now, this brings us to the circumpolar stars. Again, this is the idea that some stars never rise and set. So here again, we've got our guy in North Africa, and as he looks to the north, he sees the pole star, and these stars go around and around. If he was to keep watching, he'd see they never set. And here we see a long exposure photograph. And so you can see the trails of the stars. So the pole star is here, and the stars close to the pole are going around, and everything goes around and around and around. Some things go down below the horizon and back up. That would be things that are about here. and some things just go round and round. Likewise, if you're in the south, you'll have a different set of circumpolar stars. And so they just go around and around. But this depends on your location. So here I've got a demonstration of what happens with location. So here we consider somebody who's standing at 45 degrees north. So here's the Earth, here's the horizon, the equator is here. And here we have the star Castor, which is one of the twins in Gemini. And it's going to go around and around. Most of the time it's above the horizon, spends a little bit of time below. On the other hand, Sirius here is going around and around. It's above the horizon for a little while, but it spends more time below the horizon. And clearly there are some stars down here we don't see, and there are some stars here that we'll see all the time. If we then go further north, here we're at 70 degrees north, so here's our horizon now, and it's the same stars. We've got Sirius and Castor, and here's the North Celestial Pole. And now Castor is a circumpolar star. It never goes below our horizon, so it's going around and around and around. And if we go all the way to the North Pole, Castor goes around and around. In fact, all stars go around and around, and we'll never ever see Sirius. On the other hand, if we go to the equator, so here we're at the equator, here's the Earth, here's the celestial equator, and now all stars go around, and there are no circumpolar stars. So here's Castor going around and around, half the time up, half the time not, and likewise with Sirius. If we go to the south, now we're in the southern hemisphere at 45 degrees south, and here we have the horizon, and now Castor is the star that we barely see, and Sirius is the one we see most of the time. And then at the South Pole, we're again going to see Sirius all the time and never see Castor. Now let's back up to this 45 degrees. So here we've got Castor, and we're seeing it most of the time. If we, at our latitude, at 40 degrees, we see Castor a little less because we're tilted a bit more, but not quite as much as at the equator. I grew up at 54 degrees north, and so for me, Castor is up even more, and I'm even less likely to see Sirius. You can see here at 70 degrees north within the Arctic Circle, Sirius is hardly up at all. And so for me, there are many more circumpolar stars where I grew up than there are to be seen from Colombia. Depending on where you're from, you'll have different experiences of how you see the sky move. Now there's another concept that I'd like to introduce, and that is the ecliptic. And this is a way of thinking about the sun. We know that the Earth goes around the sun. However, from an observational point of view and trying to just model what the sky looks like, we can pretend the Earth is stationary and that the sun is moving. Now, over the course of a day, the sun will go around the Earth once. However, over the course of a year, it also moves through the sky as we, in fact, move around. And so it then defines a plane, and this is basically the plane of the Earth's orbit, and we call this the ecliptic. So here we've got the Earth, and here's the Earth's equator, and we've got the celestial sphere, and then you don't see the sun just anywhere on the sky. It can't be up here or down here. It'll be somewhere in this plane. And so you can see here that it's going to be highest in the northern sky at the summer solstice, and highest in the southern hemisphere at the winter solstice for the northern hemisphere. And so this plane that we can see, that is where the sun will be at some point during the year, is called the ecliptic. The term comes from eclipse, because it has to be in that plane for there to be an eclipse. This is probably a more conventional way of thinking about what we're seeing. And so here you've got, let's say, well, it's not December, it's January, but here we have the Earth in December. And if the sun, if we could see past the sun, if we could see the stars in the sky during the day, which we could see if we didn't have an atmosphere, then what stars would we see? Well, here's the Earth, we're looking at the sun, the stars that would be behind it are Capricorn. So actually, the stars in Capricorn you cannot see during the month of December, and the stars that will be up in the middle of the night are Gemini. Then come March, we've moved around, so now the stars that would be the other side of the sun would be Pisces, and the stars that we can see at night will be Virgo. Likewise in June, which is when my birthday is, I'm a Gemini. If I could look past the sun and see them, I would be able to see Gemini. That's what defines the birth signs. However, what I can see is Capricorn. And so this plane that is defined by the Earth moving around the sun is called the ecliptic, and the signs of the zodiac are the constellations that allow us to define where the sun is and how that's moving. So to kind of summarize that idea of the ecliptic, it's just the plane of the Earth's orbit around the sun. In celestial sphere talk, it's the apparent orbit of the sun around the Earth. It's defined by the zodiac, so there are actually 88 constellations and only 12 or 13, and you can ask me about that, where the sun can be at some point during the year. And actually the zodiac was originally used as a way of keeping time. You know where the sun is and you know where it's going to be next, and so that allows you to keep time. And so, for instance, February is the water carrier, which is when the thaw comes. March is Aries, which is a fertility symbol, which marks spring. Virgo is the Virgin, but it's also to do with harvest, and that's in September, and so on. And so it's very Northern Hemisphere centric because it was developed in the Northern Hemisphere. And just to emphasize, in case any of you are in doubt, astronomy is science and astrology is not, and I did post a link to the talk that I've given on this subject in more detail. Now, last thing I want to do is just talk a little bit about if we could see the stars in the sky and we could use them to judge where the sun was, we'd be able to see something like this. So I'm looking south, I've got a horizon, I can see directly to the south, I've got an east direction and a west direction, and here are some of the stars in the sky. And the sun right now is in Sagittarius. And the question is, on the same day, which constellation would the sun be closest to at sunset? And so, here's the sun in Sagittarius. Would it be in Aquarius, Capricorn, Sagittarius, Scorpio, or Libra? Now, we know that the sun is going to rise in the east, be at its highest point in the south at noon, and then drop down and be at its lowest point in the west and set. So which constellation will it be in? Well, remember that the reason that the sun appears to move is because the Earth is moving, and in fact, over the course of a day, it will stay in the same constellation. It takes about 30 days for the sun to move to the next constellation and then to the next. And so, on the same day, all of these constellations move around with the sun will still be in Sagittarius. Another look at this. Here I have a view of the sky, again, east, south, west. This is my horizon, and I can see these constellations, and the sun is currently in Cancer. What time of day is this? Well, you should all know the sun rises in the east, it's close to the eastern horizon, so it must be morning, fairly early morning. Here we have the sun in Aries. What time of day is this? Well, now the sun is fairly high, it's in the southwestern sky, so it must be mid-afternoonish. Noon would be when the sun was here, and it's setting down here, so this is early to mid-afternoon. Now, are these the same day? So here we've got the same set of constellations in the sky, and we've got the sun in Cancer here, and in Aries here. Actually, this one would be sometime around March or April, and this one would be July. Remember that the sun stays in Cancer over the course of a single day, so all the constellations rise and set along with the sun. And that's all we're going to talk about for today, and you can ask me questions when I see you.